Hello everyone, and welcome back to another Geostats lecture video. And in this lecture video I want to go through the output of a spatial regression. And in this specific example I'm going to go through the spatial lagged X model. It's going to be similar to the spatial lagged Y, but we're going to go through both. But in this video I want to go through spatial lagged X. And I want to highlight the importance of something called direct and indirect effects. And so this is the output from a regression in R. And what I want to draw your attention to are a couple of things. So the first thing we have is we have this R squared right here. Oh, maybe not covered up so much. The R squared and the p-value. Right, so these are the exact same thing that we've seen before. Right, the R squared and the p-value, that interpretation doesn't change. Right, our model is still explaining, in this case, about 11% of the total variation, and it is statistically significant. Now, what I do want to draw your attention to are the coefficients and the estimates. So ignoring the fact that this is a garbage model and none of the variables are statistically significant, let's take a look at the estimates and then talk about what they do and don't mean. So in this case, we have 3 variables, and then we have this lag of 3 variables. So this lag right here, right, this is the spatial part. Right, this is that idea that we're incorporating the values of our neighbors, right, the lagged mean that we spent so much time talking about before. Right, this is where this shows up in the output. So this lag dot, and then males 14 to 17 and white. And again, this is a garbage model. Don't worry about the specifics. But what I want to draw your attention to is the fact that with a spatially lagged X, so this is the lag X model, right? This lag dot, this is the spatial part. This part up here, where it looks just like a normal model, this part up here, right? This is the non-spatial part. Right, and so here's where things get a little tricky. For the lag X model, right, the estimates, right, these are the beta coefficients, right, the beta coefficients here versus the theta coefficients down here. So these are theta coefficients, these are your thetas, these are your thetas, and these right here, these are your betas. Again, non-spatial part beta, spatial part theta. So what I want to do is I want to throw 2 terms at you, and we've kind of talked about them before, and that's the idea of direct effects and indirect effects. Okay. So for the lag X model, this is actually pretty straightforward in terms of how we get them. When we're going to talk about the lag Y model in a minute, it's not quite so straightforward, which is why we have this thing down here, which we'll talk about in just a second. But for the lag X model, right, the non-spatial part, so the betas, right, these are the direct effects. But I'm not going to draw that conclusion because I want to make sure that you understand that in the lagged Y case, right, it's not quite so one-to-one. So the direct effects, right, down here, looking at the direct effects, for the lag X model, right, they come from the non-spatial part for the direct and the spatial part for the indirect, right, this -9 versus this -0.09. Right, so direct, indirect, and then total is the sum, right? If you add -0.09 to 0.15, you get 0.05. Right, the direct effects, and this is the key part, right? The direct effects, right, is how does changing a dependent variable impact me. Right? The indirect effect, right, is how does changing an independent variable impact my neighbor. Right, and that's why these indirect effects are linked to the spatial part, which are linked back to that lagged mean. Right, and so just to sort of, again, this is a garbage model, but just to sort of walk it through here, right, in this particular case, we were trying to regress the idea of the percent vacant based on the percent males, percent age 14 to 17, and percent white. And so, again, garbage model, right? None of these are statistically significant, but we're going to walk through it anyway. In this, if we were to take these as truth, right, we would say that raising the number of males or the percentage of males in my, in this case, it's a block group, right? Raising the number of the percent male in my block raises, right, because this is positive, has a positive association. It raises the percentage of the vacant housing. But if I raise the number of males in mine, it actually decreases, right? Decreases the vacancy in my neighbors. Or conversely, if my neighbors raise their number of males, it decreases my percent vacancy, right? So direct is me, indirect is my neighbors. And you can see that they don't necessarily have to have the same sign, right? In this case, raising mine hurts me, right? It increases my vacancy, but it decreases the vacancy of my neighbors. Or if my neighbors increase their males, it decreases my vacancy. Hopefully that makes sense. I know it's a little bit tricky. And then again, total is just the summation. So in total, right, if we were to change the number of percent males, we would see a positive association. So in total, raising the number of males across the board would raise the vacancy. Again, garbage model, don't trust these results, but that's how you would sort of go about interpreting them. And that's how, for the case of a lag X model, the non-spatial part with the betas relates to the direct, and the spatial part with the thetas relates to the indirect. And again, direct is me, indirect, my neighbor. Okay? So hopefully that makes sense. And if you have any questions, please reach out. Thank you.